Hi friends, see today I will be starting a new chapter in our second year, that is electrostatics. Okay, so if you observe carefully, in this chapter we will be having around 2 to 3 marks in MSET actually. In MSET we will be having around 2 to 3 marks, electrostatics. See, electrostatics around 2 marks hardly will be having in MSET. Okay, so first of all we have to know what is meant by electrostatics. Electrostatics and enti or static electricity. So in this actually we will be studying about electricity at rest. Electricity at rest. Suppose if electricity is in motion, then we will be going to current electricity, that is next chapter. Okay, so we will be studying about electricity or electric field at rest or electric charges at rest. Okay, so studying about electricity at rest is called as static or electrostatics. Static or electrostatics or static electricity in other words. Okay, అంతేకాకుండా studying about the electric charges and the fields produced through it or by it. This entire chapter is called as electrostatics. Okay, studying about electricity at rest or electric charges at rest and the fields produces from the charges and the fields produces or produced by these charges is called as electrostatics. So first of all, let us see in this electrostatics how the charges are represented generally. So generally we have positive charge, negative charge. We will be having positive charge and negative charge. Okay, and we all know two positive charges, that is like poles or like charges will repel and unlike charges రెండు మైనస్లు అవ్వచ్చు రెండు ప్లస్లు అవ్వచ్చు, both are like charges will repel each other and both unlike charges, one plus another minus, will attract each other. These are the properties again we will be studying later on. Okay, so this is the basic phenomenon. Okay, so when charges are very like 2 pluses or 2 minus, they will be repelling each other, that's a property, and unlike charges will be attracting each other. Okay, so this is the basic phenomenon in electrostatics. Now next thing is, so generally you can call these are types of charges, positive charge and negative charge. Now what is conservation of charge? Conservation of charge ante enti? What is conservation of charge? See, this is just like conservation of mass or conservation of energy. Energy can be neither created nor destroyed. Energy can be transformed from one form to another. Potential to mechanical, mechanical to potential, mechanical to sound, like that, as said by Einstein. Same way here, conservation of charge means what? Charge can be neither created nor destroyed, and the total charge is constant, and it can be transformed from one body to another body by friction. Okay, so generally it is given by Q is equal to plus or minus Ne, very, very important formula while numericals. Charge is given by plus or minus Ne. Conservation of charge and ఏంటంటే charge can be neither created nor destroyed, just like energy, and it is total charge is constant, and it can be transformed from one body to another body, just like the energies. Okay, now what is here N? See, Q means charge. Q is charge here. It is measured in coulombs, SI unit, scientist name. So the unit of charge is coulombs. It is named after scientist, SI unit. And here plus or minus ante the charge may be plus charge or negative charge, positive charge or negative charge. And N is a number, integer. N is an integer. That means 2, 1, 2, 3, 4, so on. So N cannot be 1.5 or 2.5 or 3.5 like that. It is complete పూర్ణాంకం అన్నమాట, integer. So the value is always 1, 2, 3, so on, or -1, -2, -3, so on, like that. Okay. So this is how you represented the conservation of charge, that is Q plus or minus n. And E is charge of electron. Charge of atom is 1.602 into 10 to the power -19 coulombs. So that is the standard value we will be using in numericals. Okay, clear? So that is about the conservation of charge. Now let us go still further. Okay, after learning about the conservation, let us see what is the famous law, Coulomb's law. Okay, Coulomb's law in electrostatics. And please make a note, this law is valid for point charges. This law is valid for point charges. Point charges మాత్రమే ఈ law valid అవుతుంది. If the charge is distributed, this law cannot be applied. Again, we have to go for another process by doing integration, by considering the small elemental length. Okay, later on we will be studying. Now, what is Coulomb's law? For example, there are two charges separated by some distance, point charges. Let there be Q1, Q2 charges, and the distance between them be, say, R. Let the distance between them is R. Make a note, these two charges are point charges. Okay. Now what happens? See here, this is first charge, this is second charge. Now let us calculate Coulomb's law. What is Coulomb's law? Coulomb's law is generally given by K, Q1, Q2 by R square or D square. And here K is the constant, which is equal to 1 by 4 pi epsilon. K is the constant, and which is 1 by 4 pi epsilon. 1 by 4 pi epsilon it is. And we also know the property also. Okay, we also know the property. What is the property here? Force of, see, already in gravitational, told you gravitational is attractive force. But here Coulomb's is attractive as well as repulsive. ఎందుకంటే two like poles ఏమవుతుంది, repel అవుతుంది, unlike poles will attract. So force of attraction or repulsion is directly proportional to the product of the charges and is inversely proportional to the square of the distance between them. This is the actual Coulomb's law. When you combine both these, you are getting this equation. Removing the proportionality, introduce constant K, and this constant K is nothing but value 10 into 9, 10 power 9 units, Newton meter square per Coulomb square. Please make a note here. This epsilon is called as permittivity of the medium. Permittivity of the absolute medium. Of the absolute medium. So what does he state here? Here charge 1 is there, charge 2 is there. So what happens? On this 2, this will be acting. So what is the force on 2? Due to 1. Force on second charge due to 1. Same thing. K, Q1, Q2 by D square. In the same fashion, what is force? Because both are same charges. Repulsive that side. Now what is the force on here? Force on first charge due to 2. In this direction, repulsive force. Again same. Q1, Q2 by D square or R square. So if you observe carefully, 2 equal and unlike, you can see. Force on 1 due to 2 this direction. And what is this one? Force on 2 due to 1 this direction. So these are what? Equal and opposite. You can observe, see. 2 equal and opposite force. That is Newton's third law again. What is saying here? Again Newton's third law. What is Newton's third law? Equal and opposite reaction. Action is equal to minus reaction. So here the force is acting in this direction, repulsive. Force on 1 due to 2. Here force on second charge due to 1. Same equal forces but in opposite direction. Therefore action is equal to minus reaction. లేదా F12 is equal to minus of F21. Clear? Very, very important concept this one. Again from Newton's third law. So here if you observe carefully, what is epsilon? Permittivity of the absolute medium. That means epsilon can be also written as epsilon naught r, where epsilon naught r is relative permittivity or dielectric constant. దీన్ని ఏమంటాం? Relative permittivity of the medium or dielectric constant K. And not only this one is free space, permittivity of free space. Okay? And the same fashion, this value in air or vacuum, its value is taken as 1. Then what happens here? Epsilon is equal to epsilon naught. In air or vacuum, epsilon naught r, relative permittivity, is taken as dielectric constant taken as 1 value. So now the epsilon become equal to epsilon naught. Therefore, ఇక్కడ ఒక విషయం మీరు గమనించాలి. See, F is equal to K into ఇక్కడ ఏం రాసాను? 1/4 కదా రాసేద్దాం. Very important thing here. You have to understand. F is equal to 1/4 pi epsilon, where K, that value, Q1 Q2 by R square. What happens here? F is inversely proportional to epsilon. F is inversely proportional to permittivity of the medium. That means more medium, less force. Less medium, more force. Inversely proportional to the force is inversely proportional to the medium. And ఎలా రాయొచ్చు? F into permittivity absolute is equal to constant, or F1 epsilon 1 is equal to F2 epsilon 2. Please write down. Very important things one. Please copy it. Coulomb's law is very important while solving numericals later on when I explain. So finally you came to one point, that is force. That is force of attraction or repulsion is inversely proportional to the permittivity of the medium. Just now I told you. So here ఏమైంది? ఇప్పుడు మీరు చూడండి వాల్యూస్ ఏమైంది? F1 by F2 is equal to epsilon 2 by epsilon 1. So what is F1? For example, F1 air అనుకుందాం by F2 any other medium. Okay, F2 any medium. Okay, is equal to epsilon, that is medium again, inversely proportional కాబట్టి medium, by epsilon, that is again air. So దీన్ని బట్టి మీకు ఏమర్థమైంది? F air by F medium is equal to epsilon medium by F air. But what is this one? Epsilon naught R. Because epsilon medium by epsilon naught ఇక్కడ ఇచ్చాను కదా ఇందాక. Epsilon by epsilon naught is equal to epsilon naught R. అదవుతుందా? So permittivity of the medium by permittivity of the free space is equal to relative permittivity or dielectric constant. Therefore, in other words, F air by F medium is equal to epsilon R. That is relative permittivity of the medium. Relative permittivity of the medium or dielectric constant. F air by F medium is equal to epsilon. Again, from this equation you can see F1 by F2 is equal to epsilon 2 by epsilon 1. And this is medium, inversely proportional. Clear? So F air by F medium, I can take it as this thing. And this thing is nothing but again epsilon naught R. And these will be using in numericals. Clear? Any doubts? F air by F medium is equal to epsilon naught R. Right? Copy it. Any doubts? Okay. Now same thing, this is Coulomb's law in normal form. Okay. Sometimes in the examination we may be asking in vector form. Okay. Coulomb's law in vector form lo అడగొచ్చు ఎగ్జామ్ లో. వెక్టర్ ఫామ్ అంటే ఏంటి? ఫర్ ఎగ్జాంపుల్ సేమ్ చార్జెస్ ఇక్కడ తీసుకున్నాం మనం, 2 charges Q1 point charges separated by distance r. Now for example, this is r1 vector and this is r2 vector, the position vector. Q1 is at r1 vector, position vector. Q2 ఏమో r2 position vector. Now same thing ఇందాకలా మీరు అప్లై చేయొచ్చు F2. This is first charge, second F2 due to 1. అలాగే here this side F1 due to 2. Okay. Now very easy to write in vector form. Normal form ఏంటి? F is equal to K Q1 Q2 by D square. This is normal form. Normal form. In vector form, very simple, K Q1 Q2 by distance ఏం చేస్తారంటే, suppose if you want here force on 2 with respect to 1. See, force on 2 with respect to first one. అప్పుడు ఏం చేస్తారు? Q1 Q2 బాగానే ఉంటుంది, ఇక్కడ ఈ డిస్టెన్స్ మారిపోతుంది. R2 vector minus R1 vector modulus whole cube into R2 vector minus R1 vector. This is one form. This is vector form of representation of Coulomb's law. Force acting on 2, second charge, point charge due to 1 is given by K Q1 Q2 by, in the place of this D square, ఎలా రాయొచ్చు? R2 minus R1 vector whole cube into R2 vector minus R1. అదే విధంగా ఇక్కడ కూడా రాయొచ్చు. Force on 1 vector, this is force on 1 due to 2 K Q1 Q2 by force on 1 due to this one. That means R1 vector minus R2 vector modulus whole cube into R1 vector minus R2 vector. This is the vectorial representation of Coulomb's law. Very, very important place. So force acting on second due to 1 means this direction, R2 minus R1 vector whole cube into R2 minus R1. Force on 1 vector due to second one is nothing but K Q1 Q2 by R1 vector minus R2 vector whole cube into R1 minus vector R2 vector. R1 vector minus R2 vector. This is how you have to represent in vector form. Okay. So in the examination, they may be asking in any way. Very easy to write down. Nothing to confuse. Okay, clear? Any doubts? Okay, right. Now let us do one small numerical by using this Coulomb's law. Chinna numerical try chadam for this Coulomb's law. Okay. See, just now I told you a small comparison with gravitational force and Coulomb's force. Gravitational force is attractive force. Coulomb's force, attractive as well as repulsive force. Force acts along the line joining between the two center of masses. There also force acting between the line joining between the two center of mass. There is no effect of any medium between two bodies. But here, if any material is between two bodies, two charges, the force will be affected. Just now you have seen because of K value. అదొంది మీకు, ఎందుకంటే permittivity of the medium ఉంది అక్కడ మీరు చూసారు. Force air by force medium is equal to epsilon naught R. So force is affecting here. But in gravitational force, there is no effect of anything placed between the medium. So these are the small comparison between gravitational force and Coulomb's force. అదొంది మీకు అది. Now we'll solve a small numerical. We'll try to solve a small numerical. ఇది ఏంటంటే చూడండి, small numerical. In the examination they are asking these type of problems. For example, there are two identical spheres charged. In this figure you can see two identical charged spheres. Okay, two identical charged spheres, mass m. Okay, they are making an angle theta with the vertical. This is some point O. These two spheres are identical, means same, mass same, and then charged. Okay. And now what is saying is, it is making an angle theta with the vertical. Now in such cases, what is angle theta? How to calculate this theta? That is the question. Now if you observe carefully, these two are identical, same charge. Okay. So there will be repulsive force between them. Let the distance between them is some r, and let the weight be mg. And of course length also is given. I think length is given as L. Length is given as L. Now this is the tension. You can observe in opposite direction, because I told you in Newton's laws first year, tension is always a pulling force. Tension. And suppose if you draw a vertical line like this angle is theta, this is also theta from geometry. Now this force, if you observe carefully, this is tension T. So what is the component here? T cos theta. Adjacent by hypotenuse. This direction tension is T cos theta. In this direction, T sin theta. Okay, na? In this direction it is T sin theta. So this is T cos theta and this is T sin theta. Now if you observe, both are same charges. So there will be repulsive electrostatic force between them. It is same, therefore, ఈ డైరెక్షన్ ఇటు రెండు ఉన్నాయి కదా ఐడెంటికల్, అదొక repulsive, ఇదొక repulsive. And this is what? Electrostatic force. And the angle between them is how much? 90 degrees. Okay? So here if you observe carefully, what happens? Electrostatic force is balanced by which one? Component T sin theta. K Q1 Q2 by D square is balanced by T sin theta, and upward force, you can see, weight is balanced by T cos theta. So from this, if you divide equation 1, divide with 2, T sin theta by T cos theta, T sin theta by T cos theta, T sin theta by T cos theta ఏమవుతుంది? Electrostatic force by W, that is mg. Sin theta by cos theta ఎంత అవుతుంది? Tan theta is equal to Fe by mg, or theta is equal to tan inverse Fe by mg. This formula is very, very important while solving numericals. So here the angle theta is given by tan inverse electrostatic force by weight of the sphere. Clear? Please note down. Very, very important. So these type of problems will be asking in MSET and NEET level. So you have to do it properly. First of all, I am telling you, understand the concept. Concept is very, very important. Concept is very, very important, please. Because if you don't know the concept, you cannot do the problems, please. Concept is very, very important. Okay. Now let us go to the next item. After calculating this thing. Right. Now, after learning about the permittivity and angle tan theta and other things, now let us see what is meant by electric field. Electric field and ఏంటో ఒకసారి చూద్దాం. ఓకేనా? See, as I told you, see, electric field. See, electric field and ఏంటి? Just like magnetic field. The region or space around the magnet where its influence is felt, magnetic field, or the region of space around the charge where its influence is felt is also called electric field. Okay, na? Now we'll be studying about what is this electric field. Okay? And not only electric field intensity. Electric field intensity. See, See, this is a vector quantity, please, just like magnetic field induction, B bar. This is a vector quantity. Now, how to define this electric field intensity? Okay. Now, generally, this electric field intensity E is given by F by Q. Force acting on a unit positive charge. Electric field intensity define cheyochu. Force acting a unit positive charge or test charge. Sometimes you will be saying as test charge kuda anochu. Okay? Or force acting per unit positive charge. So what is SI units? Newton per coulombs. Force by charge kada. SI units ఏంటి Newton per coulombs. మీకు అర్థమవుతుందా పాయింట్స్ ఇక్కడ? సో డెఫినేషన్ అయిపోయింది. వాట్ ఇస్ ద ఫార్ములా? ఆల్రెడీ ఎఫ్కి ఫార్ములా ఏంటి? ఫోర్సు K Q1 Q2 by D square. Suppose if same charges Q into Q, that is Q square by F by kada divide చేయాలి కదా, F by Q. So when you divide with Q, what happens here? Q gets cancelled, KQ by R square. So the formula for electric field intensity E bar is equal to KQ by R square, Newton per coulomb. This formula is also very, very important while solving numericals, please. So this is the definition. It is that force acting on a unit positive charge, the ratio of force to that of positive charge. Force acting on a unit positive charge placed in an electric field. Okay, na? So that is called the electric field intensity. Intensity veru, electric field veru. Field ante the spreading of the electrical lines of forces. The region up to where its influence is there. Just like magnetic field ela cheptunna mano, the region or space around the magnet where its influence felt is called magnetic field. Electric field kuda ante. Electric field ante enti? The region or space around the electric charge up to where its influence is there. That entire boundary or that complete, this is called as the electric field. Electric field intensity ante enti? The force acting on a unit positive charge placed in that electric field. Okay na? Right. And of course, electric field intensity is a vector quantity, please. Electric field intensity is a vector quantity. Now, electric field intensity, how to calculate when so many charges are there? System of charges Q1, Q2, Q3, Q4, Qn. So many charges are there. For example, at a point P, I want E net. So many charges are there, system of charges. At a point P, I want E net, electric field intensity. So how I will get? Because vector E net, E1, E2, E3, E4, E4, all are vectors. Okay? So vectorial sum E1 plus E2 plus E3, system of charges are there. So E net, electric field net ఎలా వస్తుంది మనకి? E1 vector plus E2 vector plus E3 dot 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 En. Okay? So this is how the electric field intensity net field, net electric field intensity is got by ఇది principle of superposition కూడా చెప్పవచ్చు దీన్ని. Okay? It also called as principle of superposition. Clear? See, this chapter is very easy because in first year gravitation already I told you so many formulas. Same formulas again will be repeating here. So please take care and try to understand the subject. Now, let us see, till now I told you Coulomb's law is valid for point charges. For example, if you are given like this, uniformly distributed charge, ఒకవేళ మీకు ఇలాగా ఇలా యూనిఫామ్లీ డిస్ట్రిబ్యూట్ ఛార్జ్ ఇచ్చారు. Now for example, at a point P, okay, at a point P which is a distance A and this is length L. a point P, if I want E, electric field intensity, how I will calculate? At a point E, if I want dE bar, vector quantity, electric field intensity, how I will get this one? Because you can't apply now Coulomb's laws. F is equal to K Q1 Q, because it is only for point charge. So here charge is distributed. మరి ఇలాంటి సందర్భంలో మనం ఎలా చేయాలి ఎలక్ట్రిక్ ఫీల్డ్కి ఇంటెన్సిటీకి? You have to take a small elemental length. I told you in gravitation. Take a small elemental length dx of charge dq, which is at a distance x from P. And I told you electric field అనేది ఎలా ఉంటుంది మీకు? ఎలక్ట్రిక్ ఫీల్డ్ పాజిటివ్ నుంచి అవే, అంతే కదా? పాజిటివ్ ఛార్జ్ నుంచి అవే, నెగిటివ్ టువర్డ్స్ వెళ్తుంది. గుర్తుపెట్టుకోండి, ఎలక్ట్రిక్ ఫీల్డ్ అనేది ఇంటెన్సిటీ ఈజ్ గోయింగ్ అవే ఫ్రమ్ పాజిటివ్ ఛార్జ్. పాజిటివ్ ఛార్జ్ నుంచి దూరంగా వెళ్ళిపోతుంది. ఇది పాజిటివా? ఇది పాజిటివ్ ఛార్జ్. సో ఇక్కడ నుంచి ఇట్ గోస్ అవే ఇన్ దిస్ డైరెక్షన్. అదే నెగిటివ్ ఛార్జ్ ఉందనుకోండి, టువర్డ్స్, ఇట్ కమ్స్ టువర్డ్స్. ఫ్రమ్ పాజిటివ్ ఛార్జ్ ఇట్ ఈస్ గోయింగ్ అవే ఎలక్ట్రిక్ ఫీల్డ్ ఇంటెన్సిటీ. అదే నెగిటివ్ ఛార్జ్ ఉంటే ఇట్ కమ్స్ టువర్డ్స్. ఓకే, ఇట్ కమ్స్ టువర్డ్స్ ద negative charge. This is the basic phenomenon of electric field intensity. Goes away from positive charge and comes towards the negative charge. Now, how to get this distributed charge? So, I am considering small elemental length. ఇలాంటివన్నీ bold and ఉంటాయి elements దీంట్లో. So, out of that small elemental length dx, dq charge taken at a distance of x from that point P, where dE has to be calculated. So, how to get the E now? ఎలా వస్తుంది? ఈ ఫార్ములా ఏం చెప్పాను కదా మీకు, E ఈజ్ ఈక్వల్ టు KQ/R² కదా. ఎందుకంటే ఒరిజినల్ ఫార్ములా ఫోర్స్ ఏంటి? KQ²/R², Q1 Q2. సో వెన్ యూ డివైడ్ విత్ 1Q, దిస్ ఈస్ ద ఒరిజినల్ ఫార్ములా నౌ, ఎలక్ట్రిక్ ఫీల్డ్ ఇంటెన్సిటీ. అండ్ వేర్ K is 1/4πε0. ఓకేనా? వేర్ K is 1/4πε0. ప్లీజ్ మేక్ ఏ నోట్. ε0 value is 8.85 10⁻⁻12 coulomb square per Newton meter square, and 1/4πε0, where you are calling as K, this is equal to 9 into 10⁻9 Newton meter square per coulomb square. These values are very very important in solving problems. ε0 perimeter free space value 8.85 10⁻⁻12 coulomb square per Newton meter square. K value 1/4πε0 is 9 into 10⁻9 Newton meter square per coulomb square. These are very very important. Please make in your mind while doing problems. You have to use these things. Okay. Now this is the formula KQ/R². So ఇప్పుడు ఈ పాయింట్ దగ్గర నాకు ఆ చిన్న ఎలిమెంట్ DE ఎంత వస్తుంది? DE is equal to K. Okay. Now what is small charge? dq by how much distance it is placed from P? X. So x whole square. So DE, okay, it's a vector of course, DE K dq/x². Now from where I want it is going away. So from A to L. A is the distance here and this is total distance. This distance is L. So నాకు ఎక్కడి నుంచి ఎక్కడి వరకు కావాలి లిమిట్స్? ఇక్కడేమో A, ఇదంతా టోటల్ డిస్టెన్స్ A plus L or L plus A. This is A and this is total distance L plus A. This is how I have to integrate to get the value at that point. Therefore, this one integration is E, K constant, integral A to A plus L or L plus A, ఏదైనా ఒకటే commutative property, dq/x². But here dq and x² are different things, we cannot integrate. So you have to make it in terms of x. Now you know lambda is called as charge density, charge per unit length, dl or dx, charge per unit length. Lambda is called as charge per unit length, density, linear charge density, linear charge density, lambda is equal to dq/dl. అది దీన్ని ఎంత మొత్తం for this one I can it as lambda is equal to Q by L. Now substitute here in this one. E is equal to K I am taking outside, dq place lo lambda dx, dq place lo lambda dx by x square integral a to a plus L or L plus A. Clear? Okay, please copy it. So this is very important in advanced level when the problems are given in IIT and other levels. So here therefore E is equal to K constant, lambda is also constant, x square dx, and write as x power minus 2 dx integral a to L plus A. Therefore E is equal to K lambda x power minus 2 integration the x power minus 2 plus 1 by minus 2 plus 1 a to L plus A, or E is equal to K lambda, here minus 1 I will take it outside. Okay, I will take minus 1 outside. ఇది ఎంత అవుతుంది? minus 1 by x. ఇది చూసుకోండి, x to the power of minus 2 అంటే x to the power of minus 1. I want to solve that one. Okay, చూపిస్తాను. K lambda x power minus 2 అంటే x power minus 1, ఇది minus 1. లిమిట్స్ ఏంటి? a L plus A. సో minus 1 పైకి వెళ్ళిపోతుంది, కిందకి x వచ్చేది అంటే minus 1 బయటకు వచ్చేస్తుంది, 1 by x. లిమిట్స్ ఏంటి? a to the power of a lower limit, upper limit ఏమో L plus L లేదా a plus L. So when you solve this one, see, when you solve this one, I am rubbing this left side one. When we solve that equation, what will get? Left side E K lambda minus upper limit minus lower limit. Upper limit ఎంత అండి? L plus A minus lower limit. So minus K lambda into 1 by L plus, ఇక్కడ LCM తీసేద్దాం. Again మళ్ళీ స్టెప్ ఇంది రాయడం. Take LCM here. LCM is a plus L or L plus A into minus L plus A in bracket. So E is equal to, at that point, away from that point, from the positive charge, minus K lambda into A minus L minus A by A into A plus L or L plus A. Plus A minus A, cancel. And minus into minus plus. Therefore E is equal to K lambda into L by A into L plus A. And here, what is the total charge of the this entire one? Whatever rod is given here, lambda L. So lambda L and then Q. Therefore KQ by A into L plus A. Sometimes that small q is taken as is capital Q. You can take this small q as capital Q because the entire rod is there. Don't use small q. Capital Q and రాసుకోండి. So this is the formula, final formula. Okay? ఏమొచ్చింది final formula? Because it is distributed, charge is distributed. Gravitation కూడా చూసాం మనం. అక్కడ ఎంత వచ్చింది? GM. In gravitation chapter ఇక్కడ ఎంత వచ్చింది? K బదులు gravitation constant G. ఇక్కడ Q బదులు M వచ్చింది. GM by A into L plus A. ఇక్కడ KQ by A into L plus A. So this is how the value of E is calculated at the point P for uniformly, charge is distributed uniformly. Clear? See, please make a note, this chapter is very easy if you understand the concept. Otherwise, it becomes very difficult. It is very difficult, please. ఒక్కసారి మీకు ఈ చాప్టర్ అర్థమైపోతే దీనంత ఈజీ మరి ఇంకేముండదండి. అండ్ రిమైనింగ్ ఆల్ థింగ్స్ ఆల్సో ఈజీ ఇన్ దిస్ చాప్టర్. లెట్ us go to the next one. Same thing I told you in gravitation, what all you have dealt, same thing again repeating here. అదేంటి చూడండి. For example, see here. Like this, an arc is given. Okay. Let this angle be some theta. Okay. Theta or alpha, anything you can take. Now this is charge distributed. Let this charge be capital Q and let this be radius R. Okay, let it be radius R. Now you observe carefully, అక్కడ gravitation లో కూడా చెప్పాను మీకు, if you take a small elemental dq, so field ఎటువైపు ఉంటుంది, అవే this direction, this is field, and for this again components will be the, ఈ field కి రెండు components ఉంటాయి ఇలా, and these will be cancelled and these components will be added. దీనికి ఈ component ఉంటాయి d and ఈ component, these components will be cancelled opposite direction and these components will be added. So finally resultant will be in this direction. This is resultant, dE resultant. So in gravitation chapter already I have given this equation. So this equation in this direction E, electric field intensity E is given by, okay, 2kq by, okay, r square alpha into sine alpha by 2. Okay, 2kq, k is constant as usual, 1 by 4 pi epsilon naught. Q is charge distributed on the arc of the circle, r radius, alpha is the total angle, please. It is completely bisecting. This alpha by 2, this is alpha by 2. Okay na? And alpha is in, of course, radians. Alpha is in radians, measured in radians. And you can also calculate the length of this one, AB. What is this length? R theta. What is this length? Length is equal to R into theta, that is R alpha. Okay? You can calculate that one. And not only that, what is the linear density, linear charge density? Lambda is equal to capital Q by L, or lambda into L is equal to Q. Okay? Lambda into L is equal to Q. Clear? Lambda into L is equal to Q. And also, ఇప్పుడే చెప్పాను కదా, ఇది జనరల్ ఫార్ములా అండి. దిస్ ఫార్ములా ఇస్ జనరల్ ఫార్ములా. దిస్ ఈజ్ జనరల్ ఫార్ములా. ఈవెన్ గ్రావిటేషన్ ఐ హావ్ గివెన్ ఫర్ సేమ్ ఫార్ములా. కే బదులు అక్కడ జీ వస్తుంది, క్యూ బదులు ఎం వస్తుంది. అక్కడ మాస్ ఆఫ్ ది ఎర్త్, రేడియస్ యాజ్ యూజువల్, ఆల్ఫా అగైన్ సేమ్ యాంగిల్. సో 2kq by r square alpha sin alpha by 2. Sin alpha by 2. Okay? And please make a note, alpha is in radians, please. Radians and a pi lo unchali, not in degrees. And already you calculate this one, length is equal to this length of the arc. Length of the arc enta vachindi, r into alpha. R into alpha. This is length. Length is equal to r into alpha. Okay na? Other way, what is linear density charge? Linear charge density lambda is equal to Q by L. Total charge by length. Total charge by length. అదవుతుంది మీకు. ఇక జాగ్రత్త చూడండి, టోటల్ ఛార్జ్ బై లెంత్. సో ఇక్కడ దీన్ని ఈక్వేషన్ మార్చుకోవచ్చు కదా మీరు. E is equal to 2kq by this r square alpha. I can add r into r alpha into sin alpha by 2 and రాసుకోవచ్చు కదా. ఓకేనా? Now here if you observe carefully in this equation, lambda is equal to Q by L. But L and ఏంటి ఇక్కడ R alpha. So here you can see Q by R alpha is nothing but lambda, charge density. Put it here. 2k lambda by R into sin alpha by 2. This is the formula. Maximum you will use this formula instead of Q, because in maximum problems you will be giving in lambda only, linear charge density, not in charge. So then you can use this formula. 2k lambda by R. R is radius, sin alpha by 2. Alpha is in radians, pi's. So So this is the exact formula, final formula, 2k lambda by r into sine alpha by 2, alpha is in radians, this is E. Okay, so it is coming this away from the charge. Positive charge is away, E is going away, and for negative charge it is coming towards. Okay, shall we go to the next one? Okay, so next case, next one వెళ్దామండి. Please try to remember and practice these formulas. Next case ఏంటంటే semicircle. Semicircle. For example, this is a semicircle. This is radius r. So again charge distributed. Positive charge Q. Okay. Now this is the point O. Same way. చూడండి charge తీసుకుంటే okay, it is going away from the charge. Positive charge is away వెళ్ళిపోతుంది. This is E net coming downward direction. In such cases ఏమవుతుంది? E field E net అప్లై చేయండి ఫార్ములా. E net is given by 2k lambda by r sin alpha by 2. What is the angle in radians? Pi. Okay, what is the angle, total angle here? Pi. So pi అంటే ఎంత? 180 by 2 90 sin alpha అంటే ఇక్కడ ఎంత? pi పెట్టండి, pi by 2. pi means 180 కదా, 180 degrees. So 180 by 2 అంటే 90, sin 90 ఎంత? 1. Therefore E net 2k lambda by r. So E is the E net for semicircle. It is, the value is 2k. Okay, k is constant, 1 by 4 by epsilon naught lambda. Linear charge density r is the radius. Clear? Let us go to the next one. Please copy it. Next one, quadrant of circle. Let us go to quadrant of circle. Next one. Next is the quadrant. Positive charge. Okay. Angle 90 degrees. Okay. Resultant will be in this direction. E net. Okay. This is 45 degrees. So here also apply the same formula. E net is equal to 2k lambda by r into sine, what is the angle? 90. Okay na? So ఇక్కడ ఎంత angle? 90. ఇక్కడ ఏంటి? sin alpha by 2. Okay, sin alpha by 2 అంటే ఎంత? 90 by 2 అంటే ఎంత? 45 degrees. అదవుతుంది మీకు. ఇక్కడ ఆల్ఫా 80 మెజర్ ఇన్ రేడియన్స్. ఓకే, ఎలా రాయొచ్చు రేడియన్స్లో 90 degreesని? pi by 2 అంటే pi by 4 అవుతుంది. pi by 2 by 2, that is pi by 4 కదా. pi by 4 means how much? 45 degrees. Therefore E is equal to 2k lambda by r sin 45, 1 by root 2. So what is the angle here? You can please see what is the total angle. 90 degrees kada. 90 by 2 sin alpha ఇక్కడ ఎంత? రేడియన్స్లో 90 by 2 45 sin 45, 1 by root 2. సో దీన్ని మళ్ళీ సాల్వ్ చేస్తే మల్టిప్లై అండ్ డివైడ్ విత్ రూట్ 2 and this thing will cancel. So root 2 k lambda by r. This is the exact value for E net for quadrant of the circle. For such cases, quadrant of the circle ki ఏమవుతుంది? root 2 k lambda by r. As usual, k is constant, 1 by 4 by epsilon naught, r is radius, lambda charge density, linear. Clear? So like this you can solve different problems also. Let us go to the next one also. Infinity charge, positive charge. Infinity, positive charge. So field is in this direction, away from the charge. And the negative charge is towards. Suppose if it is a negative charge, it is towards. Suppose if it is a negative charge, some point P you have taken P, it will be towards the charge D. Okay? It is negative charge. It's a long infinity charge. Infinity long. Long and infinity note. Infinity charge, positive charge. So usually the angle length again 180. So the formula వచ్చింది కదా మనకి 2k ఇది ఎలా మార్చాం మనం lambda is equal to q by L కదా and what is L r alpha కదా so lambda is equal to q by r alpha అంటే 2k lambda by r అంతే కదా ఫార్ములా వచ్చింది రైట్ సో 2k lambda by r I'll put it here 2k lambda by r into sine alpha by 2 sine alpha is 180 by 2 sine and again 1 so what is the formula 2k lambda by r is E for infinity long positive charge infinity long positive charge 2k lambda by r in the same way negative charge could ante avutundi value but it is towards and it is going away from the charge positive charge it is coming towards the positive same value will not change negative charge kuda same thing for negative charge but the charge is towards negative charge and charge is away from the positive charge. Let us go to the next case that is semi-finite. Let us go to the next one semi-finite. For example it is finite here point P this side it is infinity and this side it is finite okay ఈ కేసులో ఏమవుతుందంటే మీకు చూడండి ఈ పాయింట్ దగ్గర you will have 2 points will be there one is in x direction one is in y direction x direction లో 2k lambda by r ఒకటి k lambda by r ఒకటి ఇంకోటి k lambda by r acting at 90 degrees and this is the resultant so for a semi finite charge and ikkada infinity ikkademo finite ilanti sandarbhamlo if this distance is r if this distance is given as r and this point the E going this side one is x direction lo k lambda by r y direction lo kuda k lambda by 2 equal forces so ఇప్పుడు ఎంత అవుతుంది 2 equal forces resultant √2 into f that is √2 into k lambda by r √2 into k lambda by r so this is for semi finite positive charge 2 equal forces acting at right angles net ఎంత అవుతుంది √2f so √2 k lambda by r r is the radius clear right I think one more is left over that is ring I think ring is left over uniform charged ring I think that will be the last one uniform electric field okay electric field intensity on the uniform charged ring so this is a uniform charged ring uniform charged ring this is center and here is the point this distance is x okay this is radius r okay clear so for the uniform charged ring q charge uniformly charged p is a point here so at this point what is d electric field intensity okay which is at a distance x this is also gravitation I told you this one E is given by ఏమొస్తుంది ఫార్ములా ఇక్కడ kqx by x square plus r square power 3 by 2 so for a uniform ring charged ring q charge capital Q at a point P, which is a distance x from the center of the charged ring. K, constant 1 by 4 pi epsilon naught q charge, x distance. At this distance, P ఎక్కడ ఉంది, x distance లో ఉంది. సో ఆ distance లో electric field intensity E ఎంత వస్తుంది, kqx by x square plus r square power 3 by 2. For example, x is equal to 0. X is equal to 0. Then what happened to E? 0. Because it comes to center. At the center, no charge is there. So E is equal to 0. So at center, electric field intensity is equal to 0. Very, very important one. At center, E is equal to 0. And also one more also I told you, I think. One more point also I told you. Please write down this one. At center E is equal to 0. Please write down. See, little theoretical part is there and numericals are also there. In electrostatics, if you understand the theory, you can solve any problem in this one. Okay? Clear? And we also have x value also here. This x value, calculate the value, plus or minus r by root 2. This x value is calculated value also you are having. X is equal to plus minus two values, okay, plus minus r by root 2, okay, plus minus r by root 2. Please note down that one. Clear? So only thing is at the center point, it's very, very important. When x is equal to 0, when x is equal to 0, that means at center E is equal to 0 because no charge at the center. Okay? Very, very important. Note down? Right. Now, if you want, you can draw a graph also in the examination. They may be asking sometimes in NEET level or MCET level. Sometimes in the exam, they may be asking a graph also. Ain't a graph? Graph for electric field intensity E, vector versus R radius. E versus radius. అది ఏంటంటే ఇదిగోండి గ్రాఫ్ చూడండి. This is the graph, y-axis, x-axis. This is positive charge uniformly distributed ring. Okay, charge is distributed like that. Now, if you draw a graph, one is positive side, another is negative side. This is the graph for electric field intensity E for a uniformly distributed charge for a ring, circular ring. Okay, so here this is positive side, x value is, you can take r by root 2, positive side, and negative side it is r by root 2, minus r by root 2 and plus r by root 2. ఇందాక చెప్పాను కదా, x value is between r by root 2 plus r by 2, root 2 and minus r by root 2 value. Clear? అంటే ఇక్కడ చెప్పొచ్చేది ఏంటంటే, సపోజ్ ఇఫ్ x is equal to 0, సెంటర్ పాయింట్లో ఈ 0 అయింది. At x is equal to 0, E is equal to 0. But suppose if x is equal to infinity, what happens? ఆ ఫార్ములా పెట్టండి. E కూడా ఇన్ఫినిటీ అవుతుంది కదా, E also infinity. If x is equal to infinity, you can put the formula there. kqx ఉంది కదా, ఇందాక ఇచ్చాను మీకు. kqx by x square plus r square power 3 by 2. x square plus r square with x infinity. ఇది కూడా ఇన్ఫినిటీ by ఇన్ఫినిటీ ఏమవుతుంది, అగైన్ ఇన్ఫినిటీ. అதாவது ఇవన్నీ సాల్వ్ చేసుకుంటే ఇన్ఫినిటీ ఇన్ఫినిటీ, infinity by infinity again infinity, so E is also infinity. At x is equal to infinity, E is also infinity. X is equal to 0, E is equal to 0. So these are the maximum values you can observe. Okay, you can see positive r by root 2 ఒకటి, negative r by root. Intensity versus radius. This is intensity and this is radius. On x-axis radius and y-axis intensity. Clear? So in the examination they may be asking for a uniformly charged ring. What is the graph and the value of radius r? They may be asking. You have to please write clearly and carefully and score marks for NEET and MSET, please. Clear? So this is how you have to explain. Now we are left over with force acting on a charged particle. Okay, force acting on a charged particle. So we all know what is the force acting on a charged particle. For example, this is the field. Okay, suppose here plus charge is there and here minus charge is there. ఒకటి ప్లస్ ఛార్జ్, ఇంకోటి మైనస్ ఛార్జ్. Q0 టెస్ట్ ఛార్జ్ అనొచ్చు. Q0 means test charge. So what will be the force here? In this direction the force will be EQ, and in this direction the force ఎంత అవుతుంది? F is equal to minus EQ, but I will write it as EQ only. One is in negative direction, one is in positive direction. Okay, na? One is F is equal to EQ. Okay, E is electric field intensity, force acting. ఇంకోటి ఏంటి అంటే it is also called as two equal and unlike forces. Two equal and unlike forces. Okay, two equal and unlike forces. Clear? So that force acting on the charge when it is placed in electric field, one is in this direction, positive side, F is equal to EQ. Another is in this direction, F is equal to EQ. Minus I am not taking because I am taking magnitude. Minus రాయొచ్చు, but I am taking magnitude. Okay, that is అందుకే EQ అని రాస్తాను. EQ0, here also EQ0. Clear? Suppose if you balance the equation here, suppose this is the charged particle, let is the mass be m, let the weight be acting downward mg, force will be in the opposite direction, F is equal to EQ. Okay na? Downward force ఇప్పుడు ఎలా ఉంటుంది? ఫీల్డ్ కి ఆపోజిట్ డైరెక్షన్ ఉంటుంది. Force is in opposite direction of the field. So here you can see EQ is equal to mg, okay, or EE is equal to mg. So from this, what is electric field intensity? Mg by E. So like this the equations can be derived. Electric field intensity mg by E or mg by Q. E and Q and out E is the charge of the electron, Q is also charge of electron. Clear? Now after this we will be dealing about motion of charged particle in a uniform magnetic field which is freely falling. So this part what I will do is, this I will be dealing in part 2. This you can take it as part 1 of electrostatics. In part 2 electrostatics I will be dealing about the motion of the charged particle moving in a electric field and also the different field lines for positive charge, negative charge, positive charge, negative charge, like that. We will be drawing field lines, electric field lines, and also thereby we will be doing some numerical problems and also electrical dipole moment. What is the formula for that one? All we will be dealing in the next topic, next part, that is part 2. Okay, right.